All right, thank you. My name is Sumant, and thanks for joining us after lunch. So we have this presentation today that talks about IoT security. We're going to be talking about defensive best practices when it comes to IoT, consumer IoT, wearables, and the industrial IoT class of products. So we have a few slides talking about some of the challenges that we have seen when we are working on these kind of platforms, both on the process side, on the technical side. And without getting too bogged down into the process side of things, we also have a couple of fun vulnerabilities and demos that we're going to show you guys that talk about how we were able to write custom applications to extract data out of an Android ecosystem that was working with a wearable. And any talk about privacy, about IoT is not complete without speaking about privacy and data, right? Fundamentally, IoT products live and operate around human beings, which means there is the discussion on PII, on personal data. So we have a quick discussion on what it means when you talk about data retention, data policies, having good frameworks and practices for doing security and privacy correctly. So my name is Sumant. I have the co-speaker Kavya with me here. I am the primary promoter of a firm called Deep Armor. It is a security consulting firm. We offer professional services in penetration testing, STL, security trainings, and so on, primarily in the IoT mobile cloud kind of the ecosystem space. Prior to my job at Deep Armor, I used to work for Sun Microsystems, for Palm, and for Intel most recently. All right, so the agenda for today. So we'll be speaking a little bit about what it means from an architecture point of view for an IoT product, right? So what is the generic blueprint? What you see in most IoT products and platforms in the market. And from a security point of view, why it's really messy. So when you talk about STL, the security development lifecycle, and the good practices for doing security, why it gets complicated. So we'll not just talk about the problems, we'll also talk about approaches. What are the paradigms for doing security right for IoT products? Not just at the ingredient level, right? So we will soon see that there are some building blocks for an IoT platform, but instead of just focusing on the building blocks, we also speak about the ecosystem, right? What kind of challenges that you see when these pieces come together, when they start communicating with each other. Kavya is going to walk you through the two demos that we have today, and also kind of an overall solution, a little bit from a process, more from a technical point of view, the security and privacy development lifecycle framework that we have, a more agile kind of a product that we use for doing security and penetration testing and assessments for these classes of products, and a couple of slides on privacy. Problems in these new kinds of devices. So needless to say, there are a whole bunch of reports in this space. Some of these headlines are from the past 12 to 18 months. The Jeep hack of Charlie Miller is kind of old now. There are newer hacks on these automobile kind of platforms, on medical devices, on smart devices such as smart home products such as the secure home gateways and so on. There was an interesting talk about a smart rifle hack as well. This was at Black Hat a couple of years ago. VPN filter and Mirai, I'm pretty sure most of you have heard about them, read news articles about them. So the point is that attacks on IoT devices are no longer research or theory, right? So these are actually happening. And now we have got that out of the way, the question is how do we address them? What kind of threats are there that we need to analyze, and what kind of frameworks we want to evolve? So before we get there, I spoke about the ecosystem and what it means when you are talking about an IoT product. So broadly, we can split an IoT platform into three logical components. At the bottom left-hand corner, you see the gateway and the nodes. These are the actual form factor devices. This is the hardware, right? But very rarely do you see an IoT product shipping just the hardware. There is often the companion phone applications and the support for Android and iOS platforms today that help these small form factor devices to do the compute, to push data to a larger ecosystem, which is there in the cloud, which has a rich set of APIs, web portals, databases, analytics, what have you, right? So broadly, it's like this app device cloud, kind of in three building blocks that make up most IoT products. So it's not just these ingredients. It's also the communication channels that exist between these components. So on the device side, you have these nodes, which are really tiny form factor devices that have a bunch of sensors that collect data, and then they push them up to the gateway. The gateway is a slightly richer stack that collects and aggregates all this data and either pushes it directly to the cloud, or it uses the mobile conduit to push data back to the cloud. And from a protocol point of view, you have these host of protocols like Bluetooth, BLE, ANT+, Wi-Fi, Wi-Fi Direct, NFC, HTTP, and so on, right? So including MQTT, which is more popular in IoT. So from a security point of view and doing SDL, so some of the challenges that we saw when we started working on these classes of products a few years ago. So we really like the Microsoft SDL framework, right? So it's very well thought of, but it's also very waterfall. So it's great for doing security for products that evolve over months, kind of have a very regular pattern when it comes to architecture, design, implementation, and so on. But in these kind of products, when we were working on them, we had these a dozen products that were meant to hit the market really rapidly in a matter of months. And then the requirements were constantly evolving. And then you have this problem of continuous integration, continuous deployment, continuous delivery, which really begs a model that is much more agile, that is much more, you go back and forth, you do the design review today, you do the threat modeling later tonight, and do the penetration testing tomorrow. So that was the need of the hour. So in addition to that, the IoT products have a long life. So take the example of, let's say, a smart fridge. If there is a security bug in your fridge, you don't want to lug it back to the store and get a new one, right? And also, once you buy a fridge, you do not want to buy another one 2 years later because there is a bug in it that cannot be patched. You want to keep it for 8 years, 12 years. So these are some of the, the considerations from a business point of view that really influence how you do security for these kind of products. Privacy is big. We're going to dive into that a bit later. And the research, presentations, conference talks for IoT is coming up, but still not yet there. If you just walk through the aisle outside, you see that most of the vendors still do application security and code analysis and so on. But what we really need, and in fact we learned this the hard way, like how do you do research into how to break into Zigbee, into Z-Wave, into 802.15.4? That's still a big challenge. On the technical side as well, so these devices collect a wealth of data. So managing and doing security for your personal data, for PII, so that becomes key. You also deal with a very limited software stack, right? So doing RSA on an IoT platform, just forget about it. So what kind of curves do you use with elliptic curve DSA for doing secure boot? That's the question you need to answer on an IoT product. So security often gets compromised. Vendors typically try to make it work first, hit the market, then they worry about security, right? So it's often very late. And the problems are not just on the device front. Like I said previously, there is also a huge cloud component for IoT. So where we are talking about multi-tier, multi-tenant architecture on, let's say, AWS, on Azure, on Google Cloud. So where you have on one physical piece of computing equipment, you could have data belonging to two different device manufacturers who are competitors of each other. How do you ensure data separation in the cloud? Right? How do you expose these endpoints to your clients but still keep them secure? So there are a whole slew of challenges there when it comes to these modern cloud deployments. So we're going to look at some of the paradigms when it comes to these primary domains when it comes to security, and also like a brief introduction about the security and privacy design development lifecycle. So Kavya is going to take over from here.
Thank you, Suman. Good afternoon, everyone. I'm Kavya. I'm the head of security and privacy at Intel Sports. So as part of this proposal for our next generation SDL, we introduce you to SPDL, which stands for Security and Privacy Development Lifecycle. As most of you are familiar with Microsoft traditional SDL, the next generation SDL, which we refer to as SPDL, it starts right from the design phase and continues all the way through production and also post-production. And the main difference with SPDL is we introduce privacy and legal into each stage of the security development lifecycle, and while incorporating a lot of industry standards that exist today. And you can see how SPDL progresses from the program inception all the way to maintenance, and then again It's a waterfall approach where it repeats throughout and goes through releases, and we enhance the security posture and privacy posture of the product. To take a look at the wearable and IoT ecosystem, it consists of three major components: the device, the mobile or companion application, and the cloud. It's not just sufficient to secure one of these components, but it's also very important to secure the interfaces, the infrastructure, and the entire ecosystem as such. As we'll see later in the presentation, the compromise of one single component could open up much more larger attack surface and could compromise the entire ecosystem, which we'll later refer to as the butterfly effect. We have the next few slides that talk about the very minimal set of requirements you need to pay attention to while designing the device, the cloud, and the mobile aspect of the IoT and wearable ecosystem. I'm not going to dive deeper into all these requirements, but few important ones are paying attention to the debug boards, paying attention to the third-party components and open source libraries that you use, and also the most important one and the requirement that is often overlooked by a lot of OEMs and vendors is the privacy opt-in, opt-out policy. So as the user of a wearable or an IoT device, when I say the user should have the capability to opt in or choose what data is being given away, and at any point in time, they should have the capability to go back and wipe any data collected so far. It could be a month old, it could be a year old, but the user should always have the capability to opt out and wipe any data that they don't want to be held anymore. And when it comes to protecting the communication interfaces and the communication protocols used by commercial or consumer IoT and wearable devices, there's not one particular standard, and this is what makes it much more challenging. There are n number of protocols, and you have to make sure that you choose the right kind of standards and that you choose the right kind of practices to securing these interfaces, which are used between the cloud, mobile, and the device aspects of the ecosystem. As I mentioned earlier, the block diagram here outlines different aspects you need to pay attention to while securing the three different components, as well as when they all come into picture together. As we'll see later in the presentation, a lot of age-old vulnerabilities, they manifest in different and drastic, darker ways when these three independent components interoperate. Now we'll take a look at a few real-world scenarios, and we have two demos for you. The first demo is of a wearable ecosystem. To give an overview, we have a wearable watch, which can connect and communicate with external sensors like heart rate monitors, you see on the left. And then you also have a companion application, so the wearable can communicate with the companion application over Bluetooth or BLE. And you also have a backend cloud infrastructure that can be used for analytics or data storage, data encryption, and all of that. And the data that transfers or the data that goes back and forth between the wearable device or IoT device and the companion app is primarily of two kinds. The first being the device commands. So you could initiate commands like factory reset, firmware update, or a complete wipe of the device from your companion app. And you could also change the BLE name or the device name and such. And the other kind of data or the data transfer from the companion app to the wearable device could be social notifications like WhatsApp, Facebook, and whatnot. The other kind of data that flows from the wearable device back to the companion app is user activity data, your steps, your calories, heart rate, and then you could also take action on your mobile app, like you can play a track, and then you can answer phone calls, and so these are the two kinds of data that go back and forth. Now, a lot of vendors, they could choose to protect this data from a network point of view, and when using Bluetooth, they could enable Bluetooth link layer encryption. So if you're an attacker looking at this data, and if the attacker is trying to analyze this data, when it is encrypted, all they would see is garbage. But what about an application sitting on the same companion app as your legitimate application, would it have access to any of this data? Would it be able to access any of the social notifications, texts, any of this data? So it turns out that any application living on the same companion phone as a legit app, it does have access to all this encrypted data, not just plain data, but encrypted data. The reason being, all applications on Android and iOS, they can subscribe to the Bluetooth service or the Bluetooth channel on which this data is being transferred and can get access to any kind of data that is available to the legit application. Now, this screenshot you see here is from the official developer documentation. It says the other abilities granted by this permission should not be used. I mean, all an attacker or a malicious app has to do is to define or declare these permissions in their manifest file to get access to the Bluetooth channel or to subscribe to the Bluetooth channel, and they would have all the data available, all the data that is available to a legit application. Now, all of the documentation says that these abilities should not be used. There are no rules in place or there is no protection in place to prevent a malicious actor or a malicious application from subscribing to your Bluetooth data. We also have a demo to demonstrate this. The class of variables we used, they use BLE, not Bluetooth, and the source code is proprietary. We did not have access to the source code. But there was a lot of existing market research where we could get hold of the format of the headers and then the messages. So we didn't need access to the source code. And then let me quickly. So on the left here, we have ADB. And on the right, we'll launch the malware application. The legit application is running in the background. The wearable device just calculates steps, heart rate, and calories. So it's going through some cycles. We are spinning the device and simulating some activity. So at the first look, we just notice a bunch of random bits and bytes in the ADB log. But we just wrote a tiny script to analyze this data. And then we realized that it is actually indeed the steps, calories, and heart rate information that was originally supposed to be available only to the application. But like you can see, the malware application now has access to all this data. So all the malware application did was subscribe to the Bluetooth service, and it has access to all this information. The second demo we have here is really interesting. It demonstrates the butterfly effect I was referring to earlier. And the ecosystem is similar. We have a wearable device that communicates with a companion application or a mobile phone. And then we also have the cloud portal where the wearable can interact with the cloud, or the companion application could also interact with the cloud to store data and all of that. And on the cloud, we have two critical features to pay attention to. One, the user portal, where the users of the wearable application can sign up or register, and then they can upload their data, they can connect with friends, and then they can monitor their activity or comment on their friends' activities. The second feature, which is only available to the admins of the ecosystem, it supports remote device management and also remote data management. So if a user ends up losing their device, or if a user wants to log their device remotely, they can reach out to the administrator, and the administrator will be able to do a remote lockdown or a remote data wipe. Now, our target pages are the sign up and registration pages. The highlighted fields you see here is what we'll use for our exploit code. What we exploit is our age-old classic cross-site scripting vulnerability. But you'll see that this age-old vulnerability, it causes a much more larger impact in the ecosystem. And it just doesn't compromise the user credentials, but a lot more. Now, the exploit scenario goes as follows. The user portal supports up to 5 friend requests to be sent to any user. And we use the first name and last name fields of a user of the registration page to craft the exploit code. And the challenge we had was the fields would only allow us to input 30 characters. So what we did was we chose 2 different users to craft the exploit. And you can probably, you must be familiar with these characters. The first attacker is Arya. So she defines the variable. And the second attacker is Jon Snow, and he uses the variable. So they end up sending the request in the same order to Cersei, who is the victim. Now, Cersei as the user, she doesn't have to click on the request. She doesn't have to accept the request. All she has to do is just log in as she would normally, and the friend request would load automatically. So once you end up sending these 2 friend requests, after Cersei logs in, the scripts get executed, and all the credentials, they get sent to the attacker's backend. You can see the credentials being recorded, and then the attacker could use all these to launch, their further attacks. Now, if the user was a regular user, it would end up compromising just the user account. But since this portal supported admin functionality, as it supported admins who have remote device management and remote data wipe capabilities, an attacker could exploit the admin's credentials, and they could end up wiping the data on all the devices in the field, or they could basically lock down all the devices in the field. So this is just a screenshot of the attack. So this results in a lot of security and privacy violations, a lot of unauthorized access to user data. Now, these are some of the aspects just to pay attention to when designing the cloud aspect of IoT ecosystem. Now, Sumant will speak about the privacy aspects and what other aspects to pay attention to when it comes to privacy of IoT devices.
Thank you. So that was a really fun example, right? So the takeaway from that previous demo was that it was not a demonstration of a cross-site scripting. Right? So cross-site scripting has existed for like 20 plus years now. But the fact that a cross-site scripting bug in a web application was able to lead us, when we found the bug, to actually break a whole bunch of devices in the field. So that talks about the butterfly effect that we wanted to come across. So anyway, so that is how the old vulnerabilities can manifest in very different ways in an IoT ecosystem. So it's not just new challenges or new kind of bugs that you see. So on the privacy point of view, we spoke about these classes of products having access to a wealth of data that is user personal, right? So these products live and operate in the vicinity of humans. Some of them live inside of you, like pacemakers, for example, and there have been attacks demonstrated against them. And when it comes to these device manufacturers, more often than not, it's these small and medium-sized businesses, startups, that make these products, and they really want to hit the market very quickly. Right? So for these kind of companies to identify, to define what is personal data, to define what is PII, that becomes really tricky. There are various checklists, cheat sheets that talk about what is PII and so on, but when you actually look into them and try to apply per product or per platform, it gets really difficult. But it's all the more important now with all the privacy regulations and guidelines that are coming up, that even if you're not a company based in, let's say, for example, Europe, but selling your devices there, you need to comply with GDPR. Right? So defining not just what is personal data, but also defining who the data owner is, who the collector is, who the processor is. And these days, data is money. So you could be a device manufacturer who collects a lot of data, but sell it to someone else who does the analytics and gives value-add services to the users. So in those cases, the intersection of your privacy policies with your partner's privacy policies and with the mobile platform privacy policies, it's really a nightmare, right? So we have dealt with some of these cases in the past. And it's not just that when you're storing data, let's say, as a cloud service operator, for example, or a user of a cloud service operator, then defining the retention and deletion policies, allowing the users to manage their own data, while complying with your country-specific regulations about data retention and legal guidelines. So all these go into the privacy planning, which all factor into the SPDL process that we spoke about earlier. So we speak about what steps of privacy need to be planned at what stage of the product development, right from writing the architecture spec, all the way to pushing the product out and maintaining it over the years. So, from a law and regulation perspective, there are a host of these. GDPR, I'm sure all of you have got a ton of emails in the past few months, and pop-ups in websites saying, accept cookies, we're tracking, blah, blah. The US has a slew of these agreements and regulations, the HIPAA, COPPA, and so on. And if any of you are in India, so there is this new data protection bill that is being debated very heavily. It's going on and going into effect very soon. And it's not just the country-specific privacy regulations, right? So there is also this new kind of behavior that we are seeing about, again, this is a side effect of a global market where you have citizens of one country living around the world, but their data should be accessible to their native home country governments. So we talk about the Privacy Shield, where there is an exchange of private data information being shareable across the borders. There are MLATs, and there is the new Cloud Act that talks about legal access to citizens' data and data by other governments related to the data being stored in the United States soil, for example. So as we see more and more of this privacy in the market, we saw the need for developing a framework for quantifying privacy vulnerabilities. I'm pretty sure all of you are familiar with CVSS, right? So the Common Vulnerability Scoring System. It's great for scoring a bug, a security bug, on a grade of 0 to 10, 10 being critical. But because there are so many breaches in terms of private data and user data being stolen and misused, so we have a work group that is working with the CVSS Special Interest Group from FIRST, where we have this framework for actually developing a similar framework for scoring privacy bugs. We have a bunch of new metrics very similar to the CIA, the scope change, and so on. So we have sections that talk about regulatory impact, the legal fines, sanctions, number of people affected, and the sensitivity of the data. So we plan to put all these in some sort of a math and come up with a score, again, very similar to that. And to just give you an example of why this is important, oftentimes the security root cause can be very simple, but the impact when you lose the data can be very drastic, right? So this is just a very simple example where there was this bug, there was this exploit that happened in late of 2016, where over 400 million records were stored from this friend finder network. The security bug itself was a local file inclusion vulnerability, fairly hard to exploit. If you run just CVSS at the face value, you get a score of 5.3, a medium. But if you look at the actual data itself being stored and stolen, and the nature of data that was stolen, then and you apply the privacy scoring tool, the score is a 7.1, a high. Yes?
So in CVSS, the temporal factor also environmental factor.
Right.
Can you use those two factors to cover that?
You can. That's a valid question, but the temporal and the environmental sections of CVSS do not directly translate to some of the privacy identifiers. Like, for example, in privacy identifiers, we talk about what is the impact from a regulations point of view, right? So are you liable for being fined for your data being breached? So that doesn't really sit with the temporal definitions or with the environmental definitions. So that is true. That is in fact one of the approaches that we're talking about, where we can map the privacy knobs into, for example, the temporal scores, right? Because you could say that the value of the data kind of dies down after some period of time. If the data is exposed today, then it may be really valuable today, but not like 2 years later, right? We have taken those into consideration. So what we are proposing is an extensions to the CVSS to offer this either as an overlay or as a separate scoring mechanism. So I'm going to wrap it up here. So we spoke a lot about SDL, IoT, security-related problems, how messy it is to do defensive security for IoT. We spoke about the security and privacy development lifecycle, why privacy is really key for weaving into the security process when you're developing a new security product, a new IoT product. The cliched shift left becomes really key. The sooner you've identified these kind of problems, it's much easier, right? So patching an IoT product is not as easy as patching your Mac or your Windows laptop. So it can be really tricky, and oftentimes they may not be able to push an update. So, and it's important not just to worry about security for the individual components. It's critical that you understand the system as a whole, look at the ecosystem, look at the interoperability, and look at the standards and the protocols. And also pay attention to those old bugs. SQL injection, cross-site scripting, they're coming back in different ways, right? And of course, data and privacy. So that's it. Any questions? If not, we will be around, and if anyone wants to come up and chat, happy to talk.